Alright, more examples of nesting conditions, but now we will add one extra layer of flexibility. First, let's extract our conditions into variables to make our code more readable. Our first condition checks if the matrix is a square matrix, so is square matrix equals to our first condition. The second one checks if the rows are of given size, but let's modify the size a bit. So if size is between 3 and 5, we are going to extract this and modify it a bit. So this is now, and rows are below 5, like that. So if it's a square matrix and is within our specified size. Now let's say that if our matrix is not a square matrix, we want to generate a matrix of 2's. So whatever happens here will happen only if the matrix is square. But if the matrix is not square, we want to generate a matrix of 2's. To do this, we're going to use another keyword here called ElseIf, like that. And the ElseIf is just like if. It requires its own conditions, and the condition that we will give it is not square matrix. So else if not square matrix. So if this condition checks out to be false, so if it says, okay, the numbers of rows and columns are not equal, we will have is square matrix equals to false. But here, since we're using the not operator, the false behind the is square matrix will become a true, and the condition for the else if is now a true. So if we get inside this else if block, we want the matrix to be equal to ones of rows and columns multiplied by 2. If at least one of these conditions is false, so even if it's not only a non-square matrix, it can be a square matrix, but out of that range, we're still going to end up in the else if condition. So here we're handling actually not only non-square matrices, but pretty much all matrices that are not in this condition. Now keep in mind that if we do end up in the first condition, regardless of what condition we have here, if both of these conditions are true, only the first one will be executed and the rest will be skipped. Now, at the end we can have an else, so the else, as we discussed earlier, is our default case. So no matter what happens before the else, if all of these if, else, ifs are false, we will always end up in our else case, if we have it. So else, we are going to create a matrix of zeros, rows and cols. All right, and let's add another nested if inside our else if condition. So here we're creating a matrix of 2's. If our matrix is vertical, we have some condition to check if the matrix is vertical. We want to create a matrix of, so we want to create our second matrix to be of ones of rows and columns multiplied by 3. In the else if, so else if the matrix is horizontal, we want this matrix to be of ones, rows, columns multiplied by 4. Now, what are our conditions for horizontal and vertical matrices? A vertical matrix is a matrix that has its rows more than the columns. So we have many rows and less number of columns. The horizontal matrix is a matrix that has many columns and less rows. So rows are less than the columns. And we also need an and here, so and. And finally, again, if we end up in our default case, the second matrix will also be of zeros, rows, columns. Now let's extract these two conditions. So is vertical matrix, is horizontal matrix, like this. And we also extract this, brackets, 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 brackets. So here we have is vertical is vertical, and here we have is horizontal. All right, now let's run it. We have 5 and 5. We end up in our first if, and it's nested if. Now, if we change it to a non-square matrix, a 4 and a 5, we actually, let's unsuppress these outputs here. So we get a matrix of 2's and a matrix of 4's. So our matrix is a non-square matrix. We get the 1's multiplied by 2. And this matrix is a horizontal matrix. As you can see, we have 4 rows and 5 columns. We also create a second matrix of 4's. Now, if I change the number of rows to 6, we get a matrix of 2's and a matrix of 3's. The 3's because this is now a vertical matrix. We have 5 columns and 6 rows. We also generate the matrix of 2's. Now, how about the default case? The default case will work if we give it a matrix of 2 and 3 maybe? No. If we give it a matrix of 2 and 2, there we have it. We're in the default case where we generate both matrices with zeros. So you can make your code even a lot more flexible by nesting your conditions using an else if. You have unlimited possibilities.